Welcome back. We are diving back into mid-70s Fender territory. It's been a while since we've had one of these in the shop. We're going to be giving this guy a full overhaul. Filter caps, tubes, taking a look at the tremolo circuit, anything else it needs, cleaning the pots, all that good stuff. This is a mid-70s in mid-76, they changed it so it had the pull-out boost on the volume. These are one of my favorite eras of these deluxe reverbs. This one actually belongs to a buddy from work who was going to do the work himself, but I'm going to tackle that for him. And so I've actually opened this up and gave some advice on what parts to get since he was going to do that work, but he's just a little bit too busy with life. And so, yeah, going to be diving into this thing. Couple quick announcements before we get started, though. Do have a free tier of a Patreon started up where I'm dropping parts lists, notes, pictures, schematic snippets from all my repairs. So go on and check that out. It's just under Technology Enterprises on Patreon. Everything there is free right now. There will be paid tiers coming later on with more material, more extra stuff, but we'll always keep the level of what's going on over there right now for free. Another big announcement, I'll be moving into a new space next month, which means I'm going to need to build some new workbenches, build some new test equipment to have a second setup. So I'll walk you guys through all that as a separate series for anyone that's interested. Okay, yeah, let's dive into this deluxe reverb. Also, quick side note, do all deluxe reverbs from this era have a hole in the Tolex right here? I swear, every single one I see has that hole. Interesting. Okay. Let's flip this thing around, get the chassis out, get to work. Couple quick notes in the back before we turn the chassis around. You can see this has a Weber Alnico speaker installed, which is great. Check this out. Is this painter's tape holding these on? We'll get that fixed up. No tube charts. This thing has, looks like it's got a original to era GE rectifier tube and a couple of PV tubes for the power side. We got a new set of tubes though to put in here. Looks like we got more electrical tape down here. Oh, this is just to mark the reverb versus the trem. In my experience, the best way to get these chassis out is to put them on their side. Remove the bolts. You can usually get a hand in there to hold the nut in place. And then also make sure to remove the strain relief for these kind of things, or I guess not for this guy, but for the power cable up there. And then you can grab by the bottom of the plate or of the doghouse or gently by one of the transformers and wiggle it out. Okay. I'll get that done. Get this thing on the bench. Okay, chassis on the bench. We can do a quick inspection of the transformers. Looks like we got a 606, 635, so 35th week of 76 for the output transformer there. And then, yeah, 632, 631, and 614. So 76, these are a great era of these amps to buy because it's basically the latest version you can get before there was a big switch to the boost on the channel for the master volume. So they're very easy to convert to the earlier circuit. Sometimes you'll get one that's a transitional year where some of the changes from the next circuit have been made. But even then, pretty easy to modify. Yeah, let's go ahead and see what's under the doghouse here. I seem to recall it was some kind of hodgepodge of various capacitors. But again, we're just going to be overhauling this thing, so we can even just go ahead and pull the tubes, because we got fresh ones going in. and we'll probably start with the filter caps here under the doghouse, and then just work our way through the rest of the amp. Oh, that's right. Please don't do this if you're working on one of these amps. Look at this. Floating around. So, yeah. And then these guys, the legs are going across. So even though these are like okay caps. Yeah, man. Okay. I remember laughing at this before now too. So yeah, we're going to pull all these caps. We're going to put good guys in there. I think we got F&Ts. Let's, before we get into all the work, let's go ahead and flip it over just so you can see a before of the inside of the chassis as well. Okay, before shot of inside the chassis, you can see some work has been done to this thing at some point. Somebody threw these oversized orange drops in there, but only for some of the caps. I seem to recall that they didn't change the bias cap, which again, like if you're going to change a cap, other than the filter caps, change the bias cap, please. And yeah, let's see what else we got going on. These look like new wires. Not sure what's up there. Original power cord, so I'm not sure why. It looks like they ran new wires to the standby switch. Which, yeah, maybe they... I don't know, it almost looks like somebody rewired... Yeah, the wiring going to the fuse. But not sure why they would have done that and nothing else. Knocking the camera around here with my head. Okay, so yeah, just to have an idea of what's going on, we are going to replace all these white Mallory caps. These are electrolytic caps. We will also be investigating why these films caps were changed out. If I have Mallory 150s, I may throw those in there instead, since they will fit the amp a little bit better. Oh yeah, there's stuff going on here with the let's see, that must be with the tone stack there. Or no, sorry. Yeah, looks like the tone stack of the tremolo. Okay. Yeah, so we'll see what's going on there. We'll do what we can to put this back to stock as needed. But if it sounds okay too, if this isn't problematic, well, yeah, I mean, we'll get there when we get there. Let's flip it back over and go ahead and do the filter caps. Okay, so yeah, we're gonna pull this mess out, get some new F&T 16 microfarad 475 volt guys in there. One thing to note, this is a difference between the earlier circuits. This is a 10K resistor. This guy's a 2.2K, which means we're dropping slightly less voltage between these two nodes, since this is a smaller resistance, which means we're going to get a higher voltage at this node than we otherwise would, which means higher voltage at the plates, which means a little bit more, plates of the preamp, which means slightly cleaner. Whereas the earlier models, so this is the, the A1172 circuit that came out between 1972 and 76. This was the amp. Whereas before that, you have like the AB763. That's the black face or black panel amps. And those have a 10K here. So I'm going to leave this in place, or actually I'm going to swap it out with a metal oxide that's similar, similar value, and just let the customer know, especially since he's a guy that knows how to work on electronics and just didn't have time to take on this work himself. I'm going to leave this as the stock value and then let him know that if he wants it to be like true AB763 or anything like that, and have lower plate voltage on the preamp to get a little bit more grid out of it, you can change this out to a 10K. But otherwise, let's fire up the soldering iron and get to work here. Let's see, so just to verify, should be grounds all all going along here. Yep. Okay. Yeah, let me find some metal oxide resistors for these guys real quick, and then we will dive in. Okay, so I lied. I could not find my 2.2K resistors in metal oxide, so we're going to do that the other way. I'm going to put 10Ks in for both. I'm going to let the customer know that that's the case, and if he wants more headroom, change this out to a 2.2K, and I'll either do that for him or he can handle it himself. And yeah, okay. Soldering iron is heated up. Let's go ahead and dive in here. So I believe I will go ahead and pull. Oh yeah, so it looks like they modified this. Okay, yeah, so might have to pull this guy too, since they modified it from how it should be done in the original, which, I mean, this is fine, is what it is. But so funny to use F&Ts here, and then ICs, and then have this. Why go to the trouble of getting nice caps, and then not going all the way? All right, let's dive in. Okay, this is interesting. I'll quit yapping and get to work here, but it seems as though they wired these in series, but on the Deluxe Reverb for the AB763, those two caps are in parallel. So I don't know if maybe someone did this work that was looking at a AB763 circuit for a different Fender amp, but these should be in parallel here. So that jumper here is correct. I was second guessing myself, but just double checked on the Rob Robinette website, who is a very good source of truth for these kind of things, and he has confirmed that. So I don't know, man. we're gonna pull these caps out and rebuild this board. But yeah, you know, I've said this before, I will say it again. It's totally okay to make mistakes on these kind of things, as long as you fix your work when you can and you don't hurt yourself or anyone else. It's all part of the learning process. Looks like they did do the kind of janky thing here of not, you know, they just soldered this new cap in to the leg of the old one that was in there. It's a little bit of a pet peeve of mine, if I have any. But we're going to clean all this up. See how far we can get on this tonight. These are great amps. The Deluxe Reverb, you know, it's one of those amps that some people claim is the best amp to ever get created by Fender, and that's a pretty high praise coming from a brand that made some really, really great amps in this era. Ooh. Let's see, how do we want to do this? I think I will get this guy out of here first. The Deluxe Reverb is the only amp of my own collection I have sold anytime recently. And the only one of my vintage Fenders I've sold. Which is a funny thing to say when people love these amps so much. But I had a situation where, I'm just going to tell you some stories here while I get this all cleaned up. I was playing in a band that benefited by using a Fender, and my number one pick was a 1965 Fender Bandmaster, but we played a lot of different size venues. So it got to a point where having a super reverb also made sense. Having a vibro champ also made sense, because sometimes we played places where I had to be barely on. And then the Deluxe Reverb, obviously, is one that I always wanted to have. And yeah, ended up getting one of those as well. However, I was no longer playing in that band. The Bandmaster and the Super Reverb covered basically all territory for shows I was playing. And I really did not need the Deluxe. And because the champ worked for at home, and the other guys were great for shows. So I had been thinking about selling the Deluxe Reverb, and had even gotten to the point that I was going to list it online. And then the weekend I was going to list it online, the guy I had bought the amp off of on Reverb, who lives nowhere near me or anything, got in touch out of the blue. It had been like maybe 8 or 9 years. And he said that that was the one amp he regretted ever selling. He had it since the early 80s. And wondered if I would ever be willing to sell it back to him. So I did. We packed it up. Cost way more money than it should have to ship. Ended up barely, if at all, making any money over what I had paid for it after the shipping. But also felt really good about the sale, because that amp was going home. I got to use it for some shows, put some work into it, and yeah, this guy got it back. But funny enough, also, that amp had the same exact pockmark on the front weave of the amp over the speaker grill as this one has. So, yeah, I think they all get it somehow. Okay, so yeah, if you haven't seen one of these videos of me doing the Fender boards before, I like to, sometimes you need to add a little bit of solder to get the old solder out, but it's really beneficial to just remove the old solder, get in there with some clean stuff. But yeah, you can see like that's not heating up the way it should. So we add a little fresh solder, get things up to temp. Hit it with your desoldering device of choice, whether that's solder braid or solder sucker. And then move on to the next one. Now, one thing, and maybe we'll do it on this one since it has been worked on, but sometimes you can get an accumulation of old solder beneath these boards. So it might be worth taking these couple screws out and seeing what's going on underneath. Especially, man, I'm really feeling like this red wire is new. I need to maybe double check that's not going to be jamming us up at all. Alright, we'll get a little extra in here. And if we were taking this a step further, we would do what the real pros do, the Psionic Audio and Brad's Guitar Garage, and soak these boards, these fiber boards, in isopropyl, get all the old wax off of there, and make sure that there's no points that have soaked up enough moisture that they're conductive. That is kind of a step beyond how I do things, unless it is absolutely necessary. But those guys deserve all of our admiration for keeping these amps alive to that level. Admiration and respect. Okay. Oh. Solder sucker is full. Let's see. All right, get the last of the solder out of this guy. And let's see. There are so many wires going into a couple of these joints. This guy's got, well, 1, 2, 3, 4, 5 connections. All right, got that. Let's see, is this leg going to work its way out? And in the coming months, I kind of announced it at the front of this video, but we'll be moving into that new space next month, out of the garage. Gonna have a lot more room. And it's an opportunity to kind of get things set up in a way that I was working towards in here in the garage, where there's a lot of other stuff for projects. So that's going to be very nice. But I also will be kind of redoing how I have things set up in terms of setting up my test rig. So if people are interested in seeing how that happens from scratch, please let me know. More than happy to document the process. But we'll most likely be building a box with basically building a new dummy load attenuator. So I've been looking into different DIY options there. Might go with the John H attenuator, as it is called on the Marshall forums. Let's see, are we gonna... Oh, we might have to desolder these wires. Okay. I'm not sure if you can really even see that, but no excessive solder blobs or anything like that. So we're good to just keep building. Yeah, if anybody has opinions about that, though, let me know. I think I we'll build one of those attenuators. Oh, wait, the funny thing is going to be that there's some residential people in the same building, so I can't just crank amps full volume the way that I can here at reasonable volume or reasonable times a day. Which, you know, that's kind of just part of the trade-off. So let's check that. Just use my continuity meter here. Yep. Okay, so these two caps are going to be in parallel for that very first stage. Yeah, so I need to build an attenuator and a load box. I want to build that up in a way that I can easily have a signal generator going into it. And then also an oscilloscope going to the output so that I can monitor amps. I may even build two of those so that I can have an amp that is being kind of like warmed up and tested after repair to monitor for any issues while I'm working on another amp. I'm going to grab my silicon. Yeah, okay. Right back. Okay, so before we go ahead and start putting this amp back together, I needed to stop and confirm with the owner that we do want to just go full AB763 circuit for this amplifier. They have confirmed that that's what they want to do. There's a couple of small differences. This is the 1976 version of this amp is the 1172 schematic, A1172. There's also an 828, I think is the other variation on this, but those schematics are virtually identical to each other between these two. Different than the AB763. The AB763 is kind of like the desired circuit most people think of when they think of a classic Fender Deluxe Reverb. And those are the ones that go for a ton of money. There's not a lot of changes. This is something that if you're comfortable modifying your amplifier, most people could handle if they've done work like this in the past. You can see some of these items here. So I have the 1172 schematic in hand. I actually pulled this from a website called fenderguru.com, and they outline the difference. If you do want to do this yourself and you don't want to follow along this video, they are a great resource. Usually Rob Robinette is my go-to for the Fender stuff. His website is really great, but the Fender Guru website actually had a really good breakdown on this and had these schematics. That's where I pulled this. You can see these things are circled. It actually lists the differences, but also shows a comparison between the two, or at least the schematic of one and the layout of the other. So yeah, we can see here the rectifier has changed from a so let's see. Yeah, okay. So right here I've got the AB763. So we can compare side by side here. We've got GZ34, 5U4GB. This is just going to basically change the voltage that you have available because these have different current handling. But this is just showing that you could put either one of these rectifiers in place and try the difference there. Now, the one thing I would warn against, some people do like to throw those solid state rectifier, the Yellow Jacket, I think is the brand. If you throw in one of those, you can exceed voltage levels for certain components of the amplifier. When you put a solid state rectifier in, your voltage is going to raise by a certain amount. And without, that in combination with the fact that wall voltage, at least in the USA, is typically higher than it was in the 1960s. I don't know about for other countries, but I would assume that's similar. You can easily end up exceeding like the 450 volt rating of these capacitors. So if you do have stock values in there, you want to be very careful with, you should be safe going between these two. Again, keep an eye on it. But if you are thinking of throwing a solid state rectifier into one of these amplifiers via one of those plug and play kind of guys, you want to make sure that you are comfortable with monitoring these voltages or have your tech do it for you to see if you are going to exceed the power rating or voltage rating of anything in your power supply or elsewhere. That can easily happen. That being said, the first difference we're going to talk about here is that there is a difference in the stock rectifier tube. In the AB763, it is a GZ34. In the 1172, it is a 5U4GB. We can do a whole separate video talking about the difference between those rectifiers. Basically, between those two, you can try each and do it to taste. In this amplifier, at least, not all amplifiers, but in this amplifier, I have seen other amplifiers, Fender amplifiers, where one had been changed out for the other, and the voltage in the amp again ended up being so high that the noise floor was raised to the point that there was an audible difference in noise and oscillation in a reverb circuit based solely on swapping that out, which was interesting to see and find. Okay, next difference is in the power supply still. This capacitor right here might be a little bit hard to see on your screen. This is the bias capacitor. In the AB763, this is a 25 microfarad 50 volt. In our 1172, this is a 50 microfarad 70 volt. To be honest, most of the time when I do modifications or repairs on these amps, I throw in a 100 microfarad 100 volt. 50, 100 microfarad, or 25. There's not going to be an audible difference here. The 50 is going to help give a stiffer bias supply. It's arguably better to have at least a 50 microfarad, if not 100, in place there, just to ensure that you are getting a nice, solid bias supply line that isn't going to waver or see too many dips. The 50 to 70 to 100 volts, again, is just, 100 volts is better than either of these two options. It gives you more wiggle room. They are going to fit on that board. If it were me, I would do a 50 or 100 microfarad at 100 volts. That's a pretty common cap value in the axial can style electrolytic. So that's probably what we'll throw in there. I can't remember what we ordered, but it'll either be a 50 or 100 at that 100 volts for this. Now the big difference, the one that stopped me in my tracks here, is this resistor right here that you can see is circled. You can see in our AB763, so what's going on here is our AC supply comes in at the transformer. The rectifier converts it to DC. That DC line goes to two places. It's coming off this tap here to go to our bias circuit. You can see there's a reverse polarity diode there, so we're only going to get negative voltage or current on the negative alternation coming to this point, which is why we're going to then, through our bias pot, get a negative voltage here to set our bias point for our two power tubes. Now, this other line is going to come up to this point, see some filtering from these first caps. When the standby switch closes, it is then going to allow current to flow through the choke and then head on to the rest of our filtering for our other stages. So 16 microfarads here, which is going to go to the screen nodes, or allow voltage at the screen nodes for the power tubes. We're then going to drop some voltage across this 10K resistor, have more filtering, 10K resistor again, and more filtering. And then this is going to, this point is going to go to the, would be here for the plate of this preamp tube. And then we again are going to come over to this point and go to dissipate to the plates of these guys as it moves backward. So why is this important, this 10K resistor? Here we have a 2.2K, which means when current's going through here, if we're following Ohm's law, at a set or at a changing resistance at the same voltage, we are going to allow more current through this 2.2K than we would a 10K, because it's going to look like a bigger restriction to current that is trying to flow through here, which is going to mean this 10K resistor is going to drop more voltage across it than the 2.2K, which means there's going to be lower voltage at this point. Okay, I was getting mixed up on which schematic I was looking at for each and confused myself here. So with the 1172, we are going to have a higher voltage at this node, which then continues on to our supplying voltage for both the preamp tubes and the plates of the phase inverter here. So what does that mean? If we're dropping less voltage here, we have higher voltage here than we do on the AB763. If we have that higher voltage available, that means there's going to be more allowable swing to the signal that's coming into our preamp tubes, which is then going to cause a situation where we have less breakup. So these 1172 amps are going to stay cleaner for a higher volume setting or at higher transients on the preamp side. So let's say you're playing one of these amps, even if you have both set to edge of breakup, that may be at a lower volume setting for the AB763 versus the 1172. This guy will stay cleaner for longer, but it also, for your dynamics in your playing, may stay cleaner than the AB763 would. Now, this is the point where I backed up and said I need to talk to the owner because I know this person personally and know that they often like to use an attenuator so that they can crank their amp to get some of that saturation out of their amplifiers at a reasonable volume, which as soon as I saw this resistor in this amplifier knew they probably are going to want the 10K resistor in their power supply to get that saturation at a lower volume, just from the dynamics of how they typically play. So this is, whereas these two changes are going to, the rectifier arguably may change some of the dynamics of how you play. I would imagine most players are not going to be able to tell the difference between the two rectifier tubes. The bias supply is a functional change. It's just going to protect your bias circuit a little bit more, make it a little more stable. This change is something you probably would hear. This is something going from a 2.2K resistor to a 10K. Both of these are 1 watt. I like to throw 2 watt or even 3 watt in there, depending on what fits well. This is something you probably will hear the difference on. Okay, so similarly, this capacitor here, we can see is a 0.01 microfarad on the 1172 versus a 0.001 microfarad. These are the coupling caps to the phase inverter, so your signal comes in from your preamp stages to then get to each side of the phase inverter where your signal is split into positive and negative alternations separately to be amplified by the push-pull circuit of the power tube stage. So this is a place where people commonly will tweak amps for sound, is these coupling caps going into the phase inverter. Now, this is something that is going to change slightly. Again, like, I don't know if I am at a point where I could hear the difference between these two capacitors. But this is something that people would typically tweak. This is a capacitor in series is going to be a high pass filter. So the higher your frequency, the more easily they're going to get through. You're basically changing the dynamic of where that cutoff is for the middle point of how high of a frequency starts to more easily get through versus not. So you're changing a little bit of the high versus low bass, or, bass versus treble response of one side of your signal. Not even for your whole signal, but just for the asymmetrical nature of the clipping that would happen when you saturate the phase inverter. So the dynamics of how the high-low relationship for one side of your phase inverter works. And again, that's something that you may hear if you are at a point where you're starting to tweak guitar amps. This is maybe worth experimenting with a little bit. Your coupling caps are often considered to be, part of, outside of like the actual tone circuit, which is going to be over here where you have your bass, treble, and mid on some amps. Response, this is a place, these coupling caps are considered places where you can kind of shape your tone. So again, that's similar to the this being something, this resistor being something that would affect the dynamics of breakup. This is a area where you're going to have a slight change in the tone. We're going to get a potentially slightly darker sound from the AB763 overall, as a culmination of all these things. Lastly, we have on the AB763 1 meg resistors for getting the actual power. So this is actually where this is not going to affect the power to the plates of the so we are going to affect the power getting to the plates. Let me back up there to the phase inverter. That's these symbols here, and we can trace that through. It's going to go through this point, go up through here, through this capacitor, and then through this point to there. But we also have this change. We are, what is that, 330K on each side, whereas on our AB763, we have 1 meg resistors there. Now, either way, those are just splitting you're ending up, because these are two equal resistors, we're going to have half of the voltage that's seen at this node at this point. Stock, it should be 77 volts on the AB763. A little bit lower voltage means this is going to saturate earlier. Part of that being a lower voltage, again, has to do with this resistor being changed to a higher value, so we have less voltage to even get there. Changing that from 330K to 1 meg, I don't know if you would really hear a difference there. Again, pretty minor change, and really that's just changing the amount of current that's going to flow through those resistors. The relationship is going to be the same between the two of those. I would have to A/B sound test that to know if I would even hear this difference. Similarly, these capacitors in the 1172, this is something that was added to a lot of the Silverface era Fenders, basically there to prevent or try to minimize the effect of oscillations on our power tubes. A lot of people just take those out straight away. They can, sometimes be something that people argue affects your tone. We'll probably pull them out, see if we have any kind of oscillation issues, and then go from there. Lastly, this 2000 picofarad capacitor in our reverb return circuit. We can see this is our circuit for our reverb. This is the driver, which then goes to our, this is the driving tube stage, I should say, from the 1287, which then goes to the reverb transformer, which matches the impedance from the output of that stage to the tank. This is our reverb tank. On the return side, we can see no capacitor here, capacitor here. And again, this is just a little bit of tone shaping to shave off some high end. I think they basically did this as a way, again, to try to minimize oscillation on the reverb circuit. But worth taking out. This may make your, or it may make your reverb just a little bit darker. But something that we can put the circuit back to stock, let the owner know about. And if he wants to play with that, he certainly can. Yeah, so that's it. That is, maybe saying that's it is funny because it is kind of a lot, but not a ton of changes really to go from the 1172 to a true AB763 circuit. That's going to be our next step. We are probably going to have to do that work this next Sunday and cut this video here so it doesn't drag on too long after the theory. But we will start by repairing that power board, putting new capacitors in there, changing out the rest of the electrolytics in the amp, performing these changes as well. We can then also talk about, you know, where these are in the layout, although we will be doing this straight away on the amp. So I can just show you there. Again, check out the Fender Guru website. I'll put a link in this video in the description so that you can check this out for yourself. They don't go into too much detail as to the effect of these changes, but they do talk further about modifying any of these amps between the circuits that are common. Pretty great resource. So, okay, so thanks for watching. We'll be ramping up the videos here once I get fully moved into the new shop. But for now, kind of trying to limp along while things are in an in-between state. So thanks for bearing with me. And pretty soon we'll be cranking these things out and showing off the new setup. So, yeah, let me know if you have questions in the comments on anything having to do with the conversion between these two. And hopefully next week we'll be doing some sound tests so you can hear what a converted to AB763 Fender amp sounds like, and see that process firsthand on the channel here. As always, thanks for watching, and we'll see you on the next one.